Okay, so last time we talked about arithmetic sequences, right? And we said those were sequences where you basically, add the same constant to each, term to get the next term. Okay, what about an arithmetic series? So remember, when you switch to series, now you take your sequence and you're going to add all of those and find the sum, okay? Well, okay, so there are two formulas for this, and we're going to actually derive these formulas, okay? All right, so what is Sn, right? How do you, like when you're adding a series, an arithmetic series or an arithmetic sequence, what exactly does it look like? So you've got your A1, right? And then the next one is A1 plus D, right? And the next one is A1 plus 2D, right? And you keep going like this until you have AN. Okay, so let's now start working backwards from the end of a sequence. Okay, if you start working backwards from the end of a sequence, how does it look? So suppose the sequence was one where suppose D is equal to 3, okay? And you've got like this sort of sequence here, okay? And suppose you know that the last term is, I don't know, 100. How would you know the one right before? Yeah. So it would be 100 minus 3, right? And what about this one? How much is this one? It's 100 minus 2 times 3, right? And the one before that is 100 minus 3 times 3. So going back here, right? So these are the first 3 terms in this series. Now let's do the last 3 terms, the last 3 terms in the series. So it's AN minus 2D plus AN minus 1D plus AN. Okay? Makes sense? Okay, now what I'm going to do, yeah.
Oh, you're just saying specifically for this, like just okay.
For any arithmetic sequence,
okay.
Right? These are, yeah.
It would start at the end.
Huh? Yeah. Okay, so this is basically, from the beginning to the very end, and then, there's like the middle here, we haven't shown it. We've only shown the first 3 and the last 3. Now we have another one. Now what we're gonna do is we're gonna write the series again, because that was so much fun. We're gonna do it again, but guess what? This time we're gonna start writing it from the back. Okay, so the last term is AN, and then the one after or before that, it's AN minus D, then AN minus 2D, plus dot, dot, dot. Now I'm going to do, these 3 here. So A1 plus 2D, plus A1 plus 2D, plus A1 plus D, plus A1. Right? Okay. Now, guess what I'm going to do? I'm going to add these 2. Why? Because it's fun. So, Sn plus Sn, that's 2Sn, equal to. Now look, if you go by columns, look at what you have. In this one, if you add these, what does that give you? A1 plus AN. Plus, what about this one? What does that give you? If you add those 2 terms. A1 plus AN, because the D's go away. What does this give you? Yeah, we're on to something here. What does this give you? A1 plus AN. Oh my God. They all give you the same thing. A1 plus AN plus A1 plus AN. Huh. Okay. They are all the same terms, a1 plus an. How many of those terms do I have? Well, 6 in this, but dot, 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 so there's like a whole bunch. How many would you have? Well, however many you are adding, right? So if this is S sub n, so suppose this was like n sub 100, you would be adding the first 100 terms. If it was n sub 250, you would be adding the first 250 terms. So if it was S sub 100, how many terms like this would you have? 100. So you would have n number of terms here. So another way I can write this is 2Sn is equal to n times a1 plus an. And so what's the sum then? Divide by 2, divide by 2. Sn is n over 2 a1 plus an. Okay? And that is the formula. So if I wanted to find in an arithmetic sequence, right? This only works for an arithmetic series, right? Because the D is built in. If I wanted to add the first, 57 numbers in an arithmetic sequence, this is the formula I would use, right? And now you see where it comes from, right? It didn't just fall out of nowhere. None of these just fall out of nowhere, okay? Now, but the thing is, though, you have to be given an a1 and an. But what if you don't have the last term? What if you only have the first one and d? What then? We have to have an option for that one. Well, let's see. Sn, we just said, is n over 2 a1 plus an. But what if you weren't given an? Well, do we have a formula for an from yesterday? An is what? A1 plus n minus 1 times d, correct? So if I simplify this is n over 2. All right, so you have 2a1 plus n minus 1 times d. Okay, that's the second formula. So here, these are the two formulas that we're going to use. And you use this one, right, when an is not known. All right? Okay. So this is why I like, so like in honors, we like to go into more of like where these formulas came from, Yeah.
On the page before, it says that an is a1 plus bn. Isn't that different than what we just did?
Where?
On the top, where it says second.
Oh, no. So that one was if you wanted to. Okay. So an. Okay. So this is an plus a naught plus dn. And what that does is, remember how we started our list with a1? Here, where is it? We started our list with a1. So at every step, we added n minus 1 d's, right? But if you started your list at a0, right? Then look at what happens. This time, you don't add n minus 1 d's, you add n d's. So you can shift your formula, right? If you started with a0, you can shift your formula and make it that. Okay? But it's generally the same. I like starting with a1. It's more common, so I like to use those. Okay. So let's go ahead and use those formulas now to find the sum. Okay, so here you want to find the indicated sum of each arithmetic series, right? Okay, so we have a series here. D is clearly 5. How many do I have here? We need to find the sum. from -3 plus 2 plus 7 plus 12 all the way to 157 with all those numbers missing over there. I mean, it's magic, right? That you could find that sum without even knowing what all those numbers are. So if I have A1 and I have AN, then the formula I'm going to use is S sub n is equal to n over 2 A1 plus AN, right? But for that I need n, and I don't know what n is. So let's find n first. AN is equal to A1 plus n minus 1 times d. So this formula is never going to go away. You're always going to have that as your go-to formula to find any missing information, okay? So what's AN here? 157, that's the last term. A1 is -3 plus n minus 1 times 5. Okay. And if I solve this, n ends up being 33. So S sub 33 is 33 over 2, -3 plus 157. $2,541. Okay. So for this one, if I have to find the 17th partial sum, that's S sub 17. Okay, now for this one, look at what I have. I have A1 given, but I don't have AN, right? So which formula am I going to use, 1 or 2? 2. So S sub 17 is equal to 17 over 2, A1, 53, plus n minus 1, 17 minus 1, times, how much is the d here? D is -22, yeah. Yes. Oh, sorry, it's 2 times 53. I'm sorry, I forgot the formula. I haven't used it in 2 years. I haven't used it in 2 years because maybe 3 years. I haven't used it in 3 years because I didn't teach it in 2020 or 2021 over Zoom. So 2 times 53. Oh my. Okay, thank you. So S sub 17 is -2091. Okay, does that make sense that it's a negative number? Yeah, right? Because the numbers are all going to be negative. Okay, so take a look at this one. This is given to you in a different form, right? This is given to you in sigma notation, and you need to find the sum from n equals 10 to n equals 32. So you're not looking for the sum of the first 32 numbers. No, you only want the sum of a partial list, right? Starting from the 10th term just to the 32nd term. Okay, so how are we going to do this one? So first of all, oh, you know what? I'm going to do something. The book makes these n's, and it's not cool. Let's change these to k's. They shouldn't be the same as the variable inside. Okay, let's change it to a k. Okay, so how much is n? If you start at the 10th and you go to the 32nd and you're including the 10th and the 32nd, how many numbers do you have?
24.
So 32 minus 10 would be 22, but that's if you don't count the 10th one. That's if you start from the 11th one. So you got to do plus 1. Okay, so that's 23 terms. Okay, so here let's take a smaller example. Let's take a smaller example. Suppose you have something like this, sigma, and you're going like n equals 3, k equals 3 to, I don't know, 7, okay? Okay, from 3 to 7, there are 4 elements, right? Yes, that's fine. But this one is saying it's 3 inclusive. So it's the third one, 4th, 5th, 6th, 7th. So it's one more, 5, not just 4, okay? So you subtract and then add 1. Okay, so that's n. Okay, what do we need for the formula, right? The first term is a sub 10, right? Which is equal to 10 plus 6, 16. The last term is a sub n, which is a sub 32, right? Well, let's just call it a sub 32. That's equal to 37. Oh no, 38. So let's plug it into the formula. Sn is equal to n over 2, a1 plus an, right? So this is n over 2, 23 over 2, the first term plus the last term, and that's 621. Okay? So remember, this is the first term, this is the last term. Okay? All right, so we'll stop here for today.